picking up where we have left off. Okay, just some things to once again look into. We have, once again, for the difference of squares, once again we have a squared minus b squared is equal to the quantity of a plus b times that of a minus b. And we also have, once again, with the sum of cubes, so we have a to the third plus b to the third is equal to the quantity of a plus b times the quantity of a squared minus ab plus b squared. And for what we have in the case of the difference of cubes, so we have the quantity of a minus b times that of a squared plus ab plus b squared. Now, some things you might encounter, especially whenever you are looking at simplifying expressions, and where you might have factors that might not be identical in both the numerator and denominator. There is one other property, and this is where we have that b minus a and a minus b will be additive inverses of each other. So we have b minus a is equal to the negative of the quantity of a minus b. In other words, if I have the ratio of b minus a to a minus b, and let's say if I reorder the terms in the numerator, so I have negative a plus b over a minus b. And if I draw out the negative sign, so negative a is going to be the opposite sign of a, plus b will be the opposite sign of minus b. And we have over a minus b. And if you notice, okay, we're going to have a minus b's will cancel out, but you have this negative sign that is going to remain. And so we have in reduction, so we're going to have negative 1. So if you have difference binomials with terms in switch order, you're going to have the reduction to negative 1. All right, now let's say that in working with rational expressions and simplifying, and let's say if we simplify the following. And we'll say, first of all, we'll just say we have x squared minus 4 all over 3x plus 6. So if I simplify this ratio, I can factor what I have in both the numerator and denominator. So for x squared minus 4, I have the quantity of x plus 2 times that of x minus 2. So again, with x squared minus 4, I have a difference of squares. For 3x plus 6, the greatest common factor is going to be at 3. And we have with factoring, we have 3 times the quantity of x plus 2. So I can have x plus 2 binomials to cancel. And so we have, in the simplest form, we end up with x minus 2 all over 3. And let's say that if we have, as another case, in terms of simplifying, and say we have 25 minus x squared And we have all over x squared minus 7x plus 10 So we have in the case of the numerator. So again, we have a difference of squares. So here we're going to have 5 plus x times the quantity of 5 minus x. For x squared minus 7x plus 10. So if I factor, and binomial factors, so we have x minus 2 quantity times that of x minus 5. And if you notice, okay, we have for x minus 5 and 5 minus x, again, the factors are not identical, but we have in terms of canceling out, okay, again, different binomials with terms in which order will be reduced to -1. And if I take the distribution in this one, so we have the negative over 5 plus x over x minus 2, and if you follow through, you can say we have -5 minus x and also you can just switch around the order of the terms in the numerator. Whereupon we have -x minus 5 all over x minus 2. And let's say that another case. And going back to adding rational expressions. And let's say that if we have 4 over 9x squared y to the third, and I have plus 36, I should say 5 over 36 x to the third y, and I have plus 1 over 27 y squared So for what we have here, we do not have the same denominator, but we can convert what we have. Now all these fractions individually are in simplest form, but if I rewrite what I have here in terms of least common denominator, so you have for 9x squared y to the third. If I express the coefficients in terms of prime factors, now 9, you have 3 times 3, so this will be 3 squared. And we have x to the second, y to the third. As for 36, x to the third, y. If I break this up in terms of prime factors, now 36 would be 4 times 9, okay, and 4 would break down to 2 times 2, 9 would break down to 3 times 3. So we have 2 squared times 3 squared times x to the third times y. As for 27, y to the second. Now 27 is a perfect cube, and this will be the cube of 3. So 27 y squared would be 3 cubed times y squared. For what we have in the case of the least common denominator, so we're looking at the highest powers of each prime factor as well as the variable factors. So we have with the factor of 2, okay, this appears once, we have 2 to the second. Also we have for 3 highest power factor, and 3 you have 3 to the third. And for x highest order, then we have an x, we have x to the third. And as for y, okay, this is going to be at y to the third. Okay, and so we have for these 3 individual rational expressions, we already have in simplest form, and so the least common denominator will be taking the highest degree multiples of what we have among the factors. So we have 2 squared times 3 cubed times x to the third times y to the third. And so for the least common denominator, so I got 2 squared is 4, 3 cubed is 27, 4 times 27 is going to be 108, and we have x to the third, y to the third. And so taking what we have, okay, for each of the ratios, so I have for 4 over 9x squared, y to the third. Looking at the denominator, okay, so 9 into 108 is going to be 12. X squared into x cubed is going to be at x. And the denominator already has y to the third. Now for the next ratio, so we have 5 over 36 x to the third times y. And if I put this in terms of the least common denominator, okay, so 36x cubed y into 108 x cubed y cubed, okay, that is going to be at 3y squared. So multiply the second ratio by 1 in the form of 3y squared over itself. As for what we have in the case of 1 over 27y squared, 27 into 108 is 4. And we don't have an x term in the denominator, so we have x cubed altogether. And we have for the y factor, we have y squared into y cubed is going to be at y. And so for what we have in rewriting, okay, the fractions. So for the first ratio, so you have 4 times 12x. So this will be at 48x. 5 times 3y squared, this will make 15y squared. And we have plus 4x cubed y. Now we have all the denominators. Okay, we'll convert to 108 x cubed y cubed. So we can go ahead and combine the numerator terms. And so we have 48x plus 15y squared plus 4x cubed y all over 108 x to the third y to the third. And that will be the final answer in this particular case.